Section 6-3, multiplication, division, and estimation with rational numbers. We're going to start by showing how to visually represent multiplication of fractions. Then we'll move on to division. We'll talk about some of the properties of multiplication and division, including exponential notation with rational numbers. Let's start by looking at a whole number multiplied to a fraction. For example, 3 times 3/4. When we looked at multiplication of whole numbers, we said we could look at it as repeated groupings. So we want to look at 3 of groups that contain 3/4. So I've got 3 circles on the screen. I'm going to take 3/4 of each one of those circles, and then I'm going to combine all of the shaded sections to see that I have a value of 2 and 1/4. So 3 times 3/4 can be represented really similar to how we did whole numbers. We can also take a look at this in another way using rectangles. If we did 3/4 of 3, we can do 3/4 times each one whole rectangle. So we start with 3 full rectangles, just like we did with the circles. Take 3/4 of each rectangle, and then group together all of the shaded sections. Now, something that we might not recognize immediately is that the answer can be written in 2 ways. We said 2 and 1/4 is one way to write that answer, but we could also write it as an improper fraction where we count the total number of pieces that are equal size. I have 4 pieces from my first whole circle, another 4 pieces from the second whole circle, and then 1 extra. So that looks like 4, 8, 9 pieces. So 2 and 1/4 is one answer. 9/4 is another answer. They're actually equal value. And when we write our answer as an improper fraction, we might notice that there's a relationship going on here between the 3 and the 3/4. With doing enough of these visuals, you'll notice that a whole number like 3 can be turned into a fraction, like 3/1. And if we're multiplying that whole number to a fraction like 3/4, we're really just multiplying straight across the top and multiplying straight across the bottom to get 9/4. So visually, we can make sense of why this is happening, and then we can start to recognize a pattern, which would be this shortcut, where you take the whole number, turn it into a fraction whose denominator is 1, and then you would multiply that to the fraction 3/4 in this case. Multiply across the top, multiply across the bottom. Notice there's no need for a common denominator here. And that's because we're not combining slices from different wholes. Instead, we're just repeating a diagram over and over. So the common denominator is already built in. What about if we wanted to multiply a fraction to another fraction, in this case, a unit fraction? A unit fraction is a fraction whose numerator is 1. So in this case, I'm using 3/4, and I'm multiplying to the unit fraction 1/2. So they're both fractions, but 1/2 is a unit fraction because the numerator is a 1. One way to visualize this is to represent 3/4 and then represent 1/2 in 2 completely separate drawings. Now, the key for this visual is to make sure that one fraction is cut using vertical lines, and the other fraction is cut using horizontal lines. And the reason why it's important to do this is because they'll form a crisscross. If they're both vertical or they're both horizontal, this won't work. So we'll represent one fraction using vertical cuts and the second fraction using horizontal cuts. And it doesn't matter which one is which as long as you have one and the other. And then we're going to overlay them so that we can see that we're taking 3/4 of 1/2. And the answer is going to be the two overlapping parts. Oops, out of order here. So I would take the section that is overlapping, and that would be my answer. And the way that we would interpret this would be to think of this as its own fraction. In this diagram, there are a total of 8 equal-sized pieces, so my denominator should be 8, and we have 3 of them shaded. Now another way to do this, I'm going to have to back my animation up, is to start off with 3/4 and then cut each of those shaded portions in half, and then you keep the part that the cut. So the half that you cut, you're going to keep the bottom half or the top half, whatever you want to consider. But either way, you get the same result, the same image, and again, you count the number of pieces that you need to make a whole, and then on the numerator is just how many of those you are considering. And again, when we look at our answers here, we might notice that there's a pattern between the original fraction, multiplication, and the answer that we're finding. We're simply multiplying across the top, 3 times 1 is 3, and multiplying across the bottom, 4 times 2 is 8. Now it's true that we could have just said, here's the rule, go for it, but it's also important to make sense of why that rule is happening. Now, I'm telling you multiply the denominators, but what does that mean visually? What happened was we took each piece and we cut it. So if we started off with quarters, so we're starting off with quarters, if I take each one of those quarters and I cut it in half, I just created 2 pieces. So for this first quarter, I just created 2 pieces. For the second quarter, I created 2 pieces. For the third quarter, I have 2 more pieces. And for the fourth quarter, I have 2 more pieces. So for each of the 4 pieces I had, I've doubled them because I cut them in half. This would also happen if I wanted to cut it into thirds. So maybe I'm starting off with 1/4. And then maybe I want to cut that into 3 pieces. So for each quarter, I'm creating 3 pieces. What used to be 1 piece now becomes 3. So instead of 1 piece, I have 3. This second piece would become another 3. The third piece would become another 3, and the fourth piece would become another 3. So we're multiplying the 4 pieces we started with 3 because we're cutting each one into 3 pieces. So we're multiplying the denominators because we're making a crisscross grid with the 2 denominators. In general, when we multiply fractions, we're really multiplying straight across the top. So if we have a fraction like a over b, and we have another fraction c over d, when we multiply them, we have a times c on top, b times d on bottom. And remember, it's always important to try to simplify. Why don't we need a common denominator? Well, let's check and see what would happen if we had one. So a over b and c over d. By the looks of it, they do not have a common denominator, so we could make one using that law of fractions. I have b and d, so my LCD in this case is going to be b times d. So my first fraction would need a multiple of d on top and bottom. My second fraction would need a multiple of b on bottom. And then if I wanted to multiply these 2 fractions, which now have a common denominator, I would just multiply straight across the top, a times d times c times b, and then I would multiply it across on the bottom. I have b times d and d times b. Well, let's group these together. I have 2 factors of b, that looks like b squared. And I have 2 factors of, whoops, 2 factors of d. So that would be like d squared. Now b squared and d squared, that just looks like b times b, d times d. And remember that when we simplify our fractions, if there's any matching factors on the numerator and the denominator, we can divide them off. I have a b on bottom and a b on top, so I can divide those off. I have a d on top and a d on bottom, so I could divide those off. Now there are 2 factors of b on bottom, so one of them is left over, and the same for the d. So after we simplify, we have a times c over b times d, which is the same thing we have for the rule that I have at the top of the screen. So short answer, we don't need a common denominator because it would divide off even if we found one. Can you find a common denominator and still multiply your fractions? Absolutely, but maybe this helped you see that it's not worth your time.